Look up at the night sky on a clear, dark night. Hundreds of billions of stars stretch across the Milky Way alone. Each one could have planets. Many of those planets could be in the habitable zone. The universe is ancient, 13.8 billion years old, and enormous. So, where is everybody? In 1950, physicist Enrico Fermi was having lunch with colleagues when the conversation turned to flying saucers and the possibility of interstellar travel. Fermi suddenly asked a simple question that still haunts us today. Where is everybody? The logic behind his question is straightforward. The Milky Way is about 100,000 light-years across, and roughly 13 billion years old. Even if intelligent civilizations are rare and travel slowly, say at 1% the speed of light, a single species could colonize the entire galaxy in just tens of millions of years. That's a blink compared to cosmic timescales. We should see evidence, megastructures, radio signals, altered starlight, something. But we don't. This contradiction is called the Fermi Paradox. In 1961, astronomer Frank Drake tried to quantify the paradox with an equation that estimates the number of communicative civilizations in the Milky Way. N equal to Rx FPX NEX FLX Phi X FCXL, where R is the rate of star formation, FP is the fraction with planets, Ne is the number of habitable planets per system, FL is the fraction where life emerges, Phi is the fraction where intelligent life evolves, FC is the fraction that develops detectable technology, L is the average length of time they broadcast signals. Early optimistic estimates suggested thousands or even millions of civilizations. But as we've learned more, especially from exoplanet surveys, the numbers have trended lower. Recent revisions place the fraction of life evolving intelligence, phi, somewhere between 0.003% and 0.2%. That dramatically reduces N. Some models now suggest we might be the only technological civilization in the entire observable universe, or one of very few. One of the most unsettling explanations is the Great Filter, a near impossible hurdle that prevents most life from reaching interstellar stage. The filter could be behind us, making the emergence of life or intelligent life extraordinarily rare. If so, we're incredibly lucky to exist. Or, the filter could be ahead of us. Civilizations might almost always destroy themselves through nuclear war, climate collapse, rogue AI, or some other existential risk before they spread among the stars. If the Great Filter lies in our future, the silence we observe could be a warning. Solution 2. They're here, but hiding. Zoo hypothesis. Advanced civilizations might deliberately avoid contact, treating us like animals in a cosmic zoo, observing but not interfering until we reach a certain maturity. Solution 3. We're just early. The universe might still be young in terms of intelligent life. Stars needed generations to produce heavy elements for rocky planets and complex chemistry. We could simply be among the first. Solution 4. Communication is hard. Maybe advanced societies don't use radio waves. They might communicate with lasers, neutrinos, or methods we can't yet detect. Or perhaps they've moved beyond broadcasting entirely, living in virtual realities, or compact matryoshka brain megastructures around their stars. If they do exist, their cities and technologies could look nothing like ours, built on ocean worlds, gas giant moons, or artificial habitats we wouldn't recognize. As of 2026, we've confirmed over 5,500 exoplanets, many in habitable zones. Projects like Breakthrough Listen continue scanning millions of stars for technosignatures. James Webb is studying exoplanet atmospheres for biosignatures. Future missions will search Europa, Enceladus, and Mars for signs of life closer to home. We haven't found evidence yet, but we're only just beginning to look in the right ways. The Fermi Paradox doesn't prove we're alone. It reminds us how vast the universe is, and how little of it we've truly explored. Whether the great silence means we're rare, early, being watched, or simply missing the signals, the question remains one of the most profound in science. Are we alone? We don't know yet. But we're finally starting to ask the right questions, and build the tools to search for answers. Thanks for watching. Like and subscribe for more daily space facts.